Hello everyone, welcome back to the channel. If you're wondering what the notice is all about, well, it's because I genuinely believe that the situation is really bad. And you know it is bad when even the Ancient One has awakened from his 3-year sabbatical to make the statement. Now, I'm not the kind of guy who likes to make conspiracy theories based on my own speculations, so I won't talk much about it. Anyway, I have hit 500 plus subscribers. Thank you all for the support. I really appreciate it. Today's video is the new episode of the Skybox series. In the day and night video, I've been asked how we can apply texture on our moon, and generally I would reply how we can do so, but this one was a bit tricky, so here we are. First, a big shout out to Westing Tyler and Tamaranian, you guys. You're breathtaking. Okay, for this I'm using Unity version 2023.1 and I have a project set up in URP. I also have the post-processing volume with main modules bloom and tone mapping with mode ACES. And we are going to use day and night shader graph from our previous episode. If you haven't checked it out already, I highly recommend you to do so. And with all of this out of the way, time to roll the new intro. Okay, we have this shader graph and I'm going to simplify it a bit so we can get going without being overwhelmed. Okay, now these nodes are responsible for our moon, and this main light direction is the forward axis of our directional light, which we are feeding from the script, which we have applied on our directional light, and we have also referenced our material here. We have also assigned that material to our Skybox, and it will look something like this in the scene view. Now to apply the texture, let's create a texture 2D property. Call it moon texture. Let's give a default texture. I'm using this texture for moon provided by NASA. I will link it below, but you can definitely use the cheese texture. Make sure to check use styling and offset and drag it in. We will sample it using sample texture 2D node. Then we will multiply it with our step node. And multiply that with our moon color. In the scene view, let's adjust our tiling and offset for the texture. And we have our moon. That's the video. If you find the video helpful, consider like, share and subscribe. Well, unfortunately, life is not that simple. We have a problem here. See what happens when I rotate the directional light. Now to keep the texture in place, we need all 3 axes of our directional light. We already have the forward axis as main light direction. Now technically we can calculate up and right axis based on that, but to keep things simple, and we are already using a script, so I'm going to create 2 vector3 properties and feed them via that script. In our script, let's also feed up and right axis to our shader. Now we have all 3 axes of our directional light, but we cannot use them as it is. We need to combine them, and for that, let's create a matrix construction node. Matrices are basically a collection of rows and columns that stores positional and rotational data of given object. Matrices are useful to perform operations like translation, rotation, scale, shear on vectors. Now take our main light right and fade it into M0, main light up to M1, and main light direction to M2. Now we have a rotation matrix, but it outputs matrix. We need vector 3. So let's take the 3x3 matrix and feed it into multiply node. We are using 3x3 because we are not dealing with translation, and also make sure that we feed it into input A of our multiply node. Now let's multiply it with our view direction. Don't worry, I will show what we are doing. So this is our directional light, and imagine that we have a view direction that points here. By multiplying it with our matrix, we have rotated it in a way that now our view direction has the same forward, up, and right axis as our directional light. So our new view direction will point this way, and we will apply our texture perpendicular to that vector, so from this plane. In our shader, we have rotated our view direction, and to apply our texture perpendicular, we will just take our multiply node's output and feed it into the UV of sample texture 2D node. And now our texture will stay in place. One final thing, there won't always be a full moon, so let's recreate moon phases. For that, let me duplicate these nodes. This will be our second moon, and I want to rotate it a bit from original, so let's create a rotate about axis node. Rotate about axis node will rotate in vector around this axis about this rotation in radians. Let's take our main light direction and feed it into in, then take main light up and feed it into the axis. Then take our rotate about axis node's output and feed it into the dot product node. Let me quickly show you what I'm trying to achieve. Okay, so we have two moons. I will use this second moon and subtract it from the original to mimic moon phases. It's not super realistic, but we'll give you the ideas. Now we have one problem. If I put the second moon here and increase the moon size, the moons will intersect. To prevent that, let's calculate min and max angle, which updates based on the moon size. In shader graph, we already have the angle in our cosine, and we are using the moon size as an angle threshold. So the moon size is basically the angle from the center point of our moon to the edge, aka radius. So if I want to rotate the second moon so that it touches the edge of the original one, I need to rotate it 2 times of our moon size. So in the shader graph, take our moon size, multiply it by 2. Now we want to rotate the second moon to both sides. So let's take our multiply node's output and feed it into negate node. Negate node will multiply any value we feed in with -1. Now let's create a lerp node. Lerp stands for linear interpolation, and it will interpolate between input A and input B based on input T, which has a valued range between 0 to 1. So if we feed 0 into T, we will get A as an output. If we feed 1 into T, we will get B as an output. If we feed 0.3 into T, we will get 30% from A and 70% from B, and so on. Now take our negate node's output and feed it into input A. Take our multiply node's output and feed it into input B. For our input T, let's create a float property, call it moon phase, set the mode to slider, which goes from 0 to 1. drag it in and feed it into input T. Then take lerp node's output and feed it into the rotation. Now we will subtract our second moon from the original. So take the output of our step node from the original moon and feed it into subtract node. Then take this step node's output and feed it into the subtract node. Now this subtraction will be absolutely fine where our moons are intersecting, but we will get negative values where our second moon is not intersecting. To fix that, we will take our subtract node's output and feed it into saturate node. Saturate node will basically clamp the values between 0 and 1. Take saturate node's output and feed it into this multiply. That's it for our shader. It will look something like this at the end. And we have our moon. Pretty cool. That's pretty much the video. If you find the video helpful, consider like, share and subscribe. Wishlist my game Cosmic Roads on Steam. If you have any questions, post them in the comments. That's it from me, and I will see you guys in the next one.